This is for Year 11 methods. It's solving trigonometric equations. It's chapter 7.9, and initially we're looking at the general solution. The general solution will involve finding a rule that covers all possible solutions. Okay, I'm solving sine of x equals a half. Find a general solution that finds all values of x. Now if I consider what does sine of x equals a half look like, I've got the sine curve that continues forever in this direction and forever in this direction. And it's going to equal a half on many occasions. It's going to be a half there and 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 there. All of those values, y equals a half. So I'm actually going to have an infinite number of solutions. So how do I come up with all of those solutions? Okay, what I'd like to do is I'd like to consider my unit circle. I'm looking for the sign being positive. All stations to Carlton tell me that sign will be positive in the first and in the second quadrant. So in the first quadrant I have theta. In the second quadrant I have pi minus theta. That's when I go around once. When I go around for the second time, I have 2 pi plus theta and 3 pi minus theta. And when I go around for the third time, I've got 4 pi plus theta and I've got 5 pi minus theta. Then I've got 6 pi plus theta, 7 pi minus theta, 8 pi plus theta, 9 pi minus theta, and that pattern continues forever and ever and ever. I can work out what theta is because I know that sine of x equals a half, and I could go to my table and look down a sine and find a half is pi on 6. So I know that theta equals pi on 6. So x is going to equal theta, 2 pi plus theta, 4 pi plus theta, 6 pi plus theta, plus, and that pattern continues forever and ever and ever, where theta is pi on 6, so it's going to equal pi on 6, 2 pi plus pi on 6, 4 pi plus pi on 6, 6 pi plus pi on 6, plus 8 pi plus pi on 6, 10 pi plus pi on 6, etc, etc, etc. And what I've got is this answer here, which is pi on 6. Then I've got this one here, which is pi on 6 plus 2 pi. And pi on 6 plus 4 pi, etc, etc, etc. So I'm finding every second one of those. So what's my general rule? My general rule is x equals pi on 6 plus all of the even valued pi's, which I can write as 2 pi n. 2 times n will give an even number. When n is 0, that's 2 times nothing, so pi on 6. When n is 1, 2 times pi times 1 is 2 pi, that gives me that answer. When n is 2, I get that answer. When n is 3, I get that answer. Okay, so that's half of the general rule. That finds all of these answers. How do I find these answers? Well, those answers of x are pi minus pi on 6, 3 pi minus pi on 6, 5 pi minus pi on 6, 7 pi minus pi on 6. They're all the odd pi's minus pi on 6. So how do I get odd numbers? 2n plus 1, pi minus pi on 6 is a way of going about it. So there's two general rules that covers all the possible values. I could, instead of expressing this in this form, I could say that I have 5 pi on 6, and then I have 2 pi plus 5 pi on 6, or 4 pi plus 5 pi on 6, or 6 pi plus 5 pi on 6. So in other words, I'm finding my first value, which is 5 pi on 6, then I'm adding 2 pi to it to find the next one. I'm adding 4 pi to it to find the next one. So I could write that general rule as x equals 5 pi on 6 plus 2 pi n. Both of these general rules give identically the same x value.